Hi, in this video we're going to talk about solving rational inequalities, but this is going to be a situation with more advanced cases. So a rational inequality obviously is the one inequality where you're going to have something with a rational expression, and if we don't have a situation when there is a rational expression on one side and zero on the other side, we're going to have to convert it to that type. So what we do is we combine multiple rational expressions on one time into the single one, factor numerator, denominator, and then go with the standard approach. But one thing that you cannot ever do is you cannot multiply both sides of an inequality by the least common denominator. That's a big no-no in this. Let's start with this example. We have 3 over x minus 1 plus 1 is greater than 0. So we need a common denominator here, which is going to be the least common denominator will be x minus 1. So then this fraction obviously stays the same. We're going to write 1 as x minus 1 divided by x minus 1. Still greater than 0. So now we can combine them. So it's 3 plus x minus 1 over x minus 1 is greater than 0. And then we're finally going to get x plus 2 over x minus 1 is greater than 0. Right? So now we're going to use a method that you probably are familiar with. We know that from here x equals negative 2 are 0 and x cannot equal 1. So we're going to do a number line. So we're going to have negative 2 here. We're going to put 1 with an open circle here, and we're going to check our signs. So the way the signs go here, you try numbers from different intervals, is going to be plus here, minus here, and plus here. Remember, this is a part 2, so I'm assuming that you already have some general knowledge on how to do that. We're looking for that to be greater than 0, not equal, so we're going to have to go from negative infinity to negative 2 open, and then it's going to also be from, that's 1. From 1 to infinity. This is our answer here. Okay. Moving on. These inequalities, so if we look at this, the denominators don't seem to match. Are they related? Yes, because the second fraction is the denominator. If I factor out 2, I'm actually going to have x minus 1, and now it looks this part, x minus 1, is common, so our least common denominator here is going to be 2 times x minus 1. Right? So what do we need? We need to multiply the second inequality, the first inequality. The denominator needs to be multiplied by 2 to make it equal, and now obviously the numerator is going to be multiplied by 2. So proceed with that. Now I think it becomes obvious that you can combine them. So we're going to have 2 times x plus 3 minus 3 over 2 times x minus 1 less than or equal to 0. The numerator will simplify to 2x. What do we have here? We have 2x minus 6 plus 3, right? 2x minus 3 is going to be, there is a plus, it's my mistake, so plus is plus 9 divided by 2 times x minus 1 is less than or equal to 0, so in the numerator is the 0 is going to be negative 9 halves, in denominator x cannot equal 1, correct? So we are going to make our number line. We're going to have what? Negative 9 halves is a 0, and 1 is going to be our excluded value, right? So we look at the signs. The way the signs are going to go here is going to be plus minus plus. And what are we left with? So we're just going to need this interval less than or equal, which means negative 9 halves will be included. So negative 9 halves to 0, that's going to be our answer. Alright, example 3. So here we have two completely different denominators. It's worth noting that the least common denominator here is going to be x minus 1 times x plus 2. First of all, these are going to be our excluded values. X cannot equal 1 and x cannot equal negative 2. And now we need to combine them. So the way we combine them is the first denominator needs to be multiplied by x plus 2. And the second denominator needs to be multiplied by x minus 1. Obviously, you do the same thing with the numerator. So our first fraction is going to become x plus 2 over x minus 1 times x plus 2. Second fraction is going to be 2 times x minus 1 divided by x minus 1 times x plus 2 less than 0. So we're going to go ahead and combine that. That's going to end up giving us 4 minus x. It's going to give us 4 minus x in the numerator, and the denominator is obviously the same, less than 0. So we have x equals 4 as our 0 here, right? And we're going to have 3 numbers. So our numbers are going to be negative 2, which is going to be open because it's an excluded value. We are going to have 1, which is also an excluded value. And we're also going to have 4, right? And that's not excluded. And then you test the signs. So the signs here are going to be, it's going to be plus here, minus here, plus here, and minus here. And we want it to be less than 0, so it's going to be less than 0 on an interval from negative 2 to 1, along with 4 to infinity. Nothing's going to be included here, it's strictly less than 0. Alright, moving on. This is example 4. We are going to have obviously x plus 1 and x plus 3, completely different. So our least common denominator is going to be x plus 1 times x plus 3. Worth noting that x cannot equal negative 1 and x cannot equal negative 3. Right? So we're going to combine these. This one's going to give you something a little more complicated. You're going to end up with a quadratic equation. So we multiply this one by x plus 3. Because we don't have that, and here we're going to multiply by x plus 1. So x minus 3 times x plus 3 over x plus 1 times x plus 3. Second fraction gets multiplied by x plus 1, so 4 minus x times x plus 1 divided by x plus 1 times x plus 3 less than or equal to 0. It looks very complicated, but after you combine all that and simplify, this is going to end up giving you 3x minus 5 in the numerator, and obviously x plus 1 times x plus 3 in denominator, less than or equal to 0. And we are ready to go ahead and take care of that. So we want to note that this here, x equals 5/3, is going to be another value, because it makes the numerator 0. Alright, so we got 3 values. We're going to plot them. So we have negative 3, which is open because it's an excluded value, negative 1, and then 5/3, which that value is fine. We're checking the signs. The signs are going to be, here is going to be minus, here is going to be plus, here is going to be minus, and plus here. We want it to be less than 0. So less than 0 is going to be from negative infinity, less than or equal to 0, from negative infinity to negative 3. Negative 3 cannot be included because it's an excluded value. And then we're also going to include the interval from negative 1 to 5/3. Negative 1 cannot be included as it is an excluded value, but 5/3 is fine. All right, moving on. So here our least common denominator is going to be x minus 5 times 1 minus x. Pretty obvious. So you can see now the idea that you multiply this one here top and the bottom by x of 1 minus x. This here top and the bottom gets multiplied by x minus 5. So we're going to have 4 minus x times 1 minus x divided by x minus 5 times x1 minus x minus, and then over here we're going to get 1 times, so multiply this by x minus 5, and this is going to be x minus 5 times 1 minus x greater than 0. Okay, there's some algebraic work that follows this, and after you get all this taken care of and simplified, you are going to get with x squared minus 6x plus 9 over x minus 5 times 1 minus x greater than 0, which the numerator is actually perfect square trinomial. It's x minus 3 squared divided by x minus 5 times 1 minus x. By the way, I didn't say here, I think you know, x cannot equal 5 and x cannot equal 1. So here we want it to be greater than 0, and we know that x equals 3 is going to be a 0, so we're going to plot this on the number line. Then go ahead and draw a number line, plot our values, so 1 which is excluded, 3 which is included, and then 5 which is excluded. Check the sign distribution. The signs here are going to go minus, plus, plus, minus. There's no change of sign at 3 because it's a double 0. We want this to be greater than 0, so it's going to be from negative infinity to greater than 0, my apologies. So it's going to be from 1 open to 3 open because it's greater than 0, and then also it's going to be from 3 to 5. So here's an important thing to notice. What happens at 3? Why do we have to write it like this, not just 1 through 5? It's because we want it to be greater than 0, and at 3 the expression will equal 0. And since it equals 0, you cannot use that. If this sign was greater than or equal to 0, then you would go from 1 to 5. But because it's greater than 0, you have to exclude a value where we actually attain the value of 0. Alright. Sometimes you have a situation when you don't have 0 on one side, and then you have to move it to the other side to properly handle that. We cannot really solve inequalities when they're in this form. We have to compare it with 0. So our first step here will be to rewrite that in this form. Okay. And then we'll follow the same procedure we just followed. We should obviously see that the least common denominator is x plus 2. So this one's already good, and this one's going to be 2 times x plus 2 over x plus 2. Alright, we have the same denominator. You can go ahead and simplify that. This will end up giving you, what are we getting here? Let's see, this is going to be negative x minus 7 divided by x plus 2 greater than 0. And we can go ahead and do it. One thing that I probably would recommend, and it's not required by any means, but if you want, you can factor out negative here to make it a little bit easier to work with. Or what's even better, if you take this inequality and multiply both sides by a negative 1, it will help you eliminate the negatives here, but then you will have to reverse the sign. So I don't want to create any more confusion here, so let me just go ahead and use it the way it is. So here we don't want x to equal negative 2. Here x can equal, what value makes the numerator 0? It's going to be negative 7. So these are our values that we're going to plot. So we have negative 2, I'm sorry, negative 7, which is closed, and then negative 2 is going to be open. Okay. The signs here are going to be this way. It's going to be minus, and then plus, and then minus. Okay. And we can go ahead and see what we need. We want it to be greater than 0, so it is going to be between -7 and -2, right? It's strictly greater than, so we do not include -7. This next one. So again, just like the previous example, we are going to move everything to one side, right? Because I want to make sure it does not, we have to compare it with 0, less than or equal to 0. Alright, so what we do next, well, first of all, let's make sure we remember that x cannot equal 3. So now we combine them together. The least common denominator here is going to be 2 times x minus 3, right? So we multiply this by 2 and this by x minus 3. So it's going to be 4 over 2 times x minus 3 minus, multiply this by, so 3 times x plus 3 minus 3, x minus 3 divided by 2 times x minus 3, right? Hold on a second, let me fix this. I don't like this confusion. Not sure what this looks like. Sometimes mistakes happen. It's good that we find them quick enough. There you go. So it's a minus 3. Still less than or equal to 0. So it's going to give us 4 minus 3x plus 9 divided by 2 times x minus 3. Right? It's not equal to 0. And we are going to get, what are we getting here? This is going to give us, once everything's said and done, this is going to be negative 3x plus 13, right? Negative 3x plus 13 divided by 2 times x minus 3, less than or equal to 0. So the numerator is going to be 0 when x equals 13/3. Number line. So we have, alright, 13/3 is a little bit more than 4, right? Because 12 over 3 is 4, so it's a little more than 4, so it's, this number goes here, 3, and 13/3 goes here. Okay, don't know what that was. Alright, so how do the signs distribute here? The signs are gonna go by testing the values. You're gonna get minus, plus, minus. We want it to be less than or equal to 0, so we're going to be on the left of 3, where 3 is not going to be included anyway. So negative infinity to 3, along with, and then we're going to go from 13/3, but it's less than or equal to, so we're allowed to include that, and we're supposed to include that 13/3 to infinity. Okay, I think we have one last example. These. So nothing's really different. We're going to move everything to one side. So x plus 7 divided by x minus 1. It's going to be greater than 5 over x minus 2. I don't know why I rewrote that. X plus 7 over x minus 1 minus 5 over x minus 2. It's going to be greater than 0. So we need the least common denominator, which obviously is going to be the product of the two that we have. So that's what we're getting. We're going to multiply this here by x minus 2 and this one here by x plus, minus 1. So we have x plus 7 times x minus 2 divided by x minus 1 times x minus 2. The second one is going to be 5 times x minus 1 divided by x minus 1 times x minus 2 greater than 0. Let me work it out since I have more space here. So what are we getting here? This is going to be x squared plus 5x minus 14. This one's going to be minus 5x plus 5 all over x minus 1 times x minus 2. So the numerator, these two terms cancel. The numerator simplifies to x squared minus 9 divided by x minus 1 times x minus 2 greater than 0. And the numerator can be factored. Let me continue here. So the numerator is going to be x minus 3 times x plus 3 all over x minus 1 times x minus 2 greater than 0. Let's remember in the beginning, x cannot equal 1, x cannot equal 2, and here x is going to be 3 and x is going to be negative 3. These are the zeros. We have 4 different values. Okay, let's plot them. So we have the leftmost is negative 3 and it's not open. Then we have negative 1, which is open. Then we have 2 that's open. And then we have positive 3, which is not open. Okay. And now we need to do our sign chart to, figure out, plug in values into the expression from the intervals and check the signs. So the sign is going to be plus, minus, plus, minus, plus. This is how it's going to be in this case. We want it to be greater than 0. Greater than 0. So it's going to be what? It's going to be from negative infinity to negative 3 along with greater than 0. So negative 1 to 2 and also along with 3 to infinity. Okay, and this is how it's done.